Alright, so there's these children, there's these three friends that have a tournament to see who's the best in playing a popular game on their phones. They each play the game 9 times. Their scores are shown. Find the mean means average, find the median, middle, range, difference, interquartile range of each player. Ooh, interquartile range. Oh, remember that. So, we know that mean means the average. Y'all know how to find the mean. You've done it over and over again. Add all the numbers and divide. What's the big kicker for the median? What do you have to do with the median? Everybody's hand should be up. How do you find the median? How do you find the median?
Middle.
How do you find the median? What do you have to do? Ariel.
You put it in order and then you by crossing out some pieces.
Yay, yes. You got to put the numbers, which your calculator cannot do yet. You got to put the numbers in order from least to greatest. So when we have data, it's better to just go ahead and put your numbers in order from least to greatest. This is why you use a pencil, and this is also why you put gaps between it, because when I was doing it, I kept missing numbers. I always miss a number when I put my numbers in order. I'm terrible about it. All right, so what's the smallest number you see under Ariana's score?
41.
41. And then I kind of just cross it out. And then there's 67, 68. Y'all should all be able to do this. You're big children. You've made it 7th grade. You know what numbers are bigger than other numbers. I hope. And then you want to make sure you've got all 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So you can go ahead and find the mean of those numbers. Now you can use your calculator. Add them all up. And what are we going to divide by? 9. Yeah. Add it all up. And then divide. Give everybody a chance. You should get 77. Now, if you didn't, you missed a number. My pen's dying. All right, if you did not get, anybody not get 77? Anybody got 77? All right, beautiful. Now, median, just like Ariel said, we go back and forth, back and forth, back and forth until you find the number in the middle. Back and forth, back and forth, back and forth, back and forth. And we end up with, ding, 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 77. Now, what happens if I have an even amount of numbers? If there's 2 numbers in the middle, what do you have to do when there's 2?
You add the big together.
You add them together and divide by 2. Beautiful. Look, your teacher taught you so well last year.
I didn't know that.
All right, well, that's what you do. When there's 2 numbers, and we're going to practice that in a minute, but when there's 2 numbers in the middle, you add the 2 numbers, and then you divide by 2. Okay? Range. Range means difference. Range means difference. Big minus small. Big minus small. So we take the big number, 98, which is also known as our maximum, and subtract our little number, which is known as the minimum. So 98, take away 41 is 57. And then we have the interquartile range, also known as IQR. Y'all remember how to find the IQR?
Nope.
Alright, so interquartile range means that we have to find the middle of the lower half, the middle of the upper half, and then subtract the 2 numbers. So because we've already found the middle, you don't use the middle number. Okay, you don't use the median. So we've got the lower quartile and we've got the upper quartile. Can you guess why we call it the lower and the upper?
Because that's where all the smaller and bigger numbers.
The lower numbers are in the lower side and the upper numbers are in the bigger side.
Is 77 just the median line? Is that all you do with that number? Or what? Okay.
Yeah, that's just the median.
Okay.
Okay? So now we got the lower half. now we have to find, well, what's the middle of the lower half? So when you go back and forth, this is where we end up with the two numbers, right? We want to find out what's between those two numbers. So we're going to do 67 plus 68 divided by 2, and that gives me 67 and a half. Doesn't that make sense? Isn't 67 and a half halfway between 67 and 68? Yeah. All right, and then you're going to do the same thing on the upper half. Back and forth. I got two numbers in the middle. I got to split it. 89 plus 90 divided by 2 gives me 90.5. So to find the IQR, I'm going to subtract those two numbers. 90.5 minus 67.5. Which gives me 22. Okay? What I want you to do is we're going to split it up, okay? This half of the room, you're going to do Deshaun's scores, okay?
It's 23.
Yeah, it's 23.
Yeah, it's 23.
It's not 22, it's 23.
Okay. You're 23. I need to see how I got 22 the first time. Alright, so 23. Alright. Oh no, because this is not 90.5. This is supposed to be... Is 90.5 halfway between 89 and 90? No, so
It's
what
supposed to
should
be
it be?
89 and a
It
half.
should be 89 and a half. This should be 89.5. $89.5, which gives me 22. Okay. All right. Going back. All right. Y'all get part B, Deshaun, and y'all get part C, Mayumis. We've had her before. Don't y'all remember saying her name, Mayumi?
Oh, yeah.
Mayumi? I don't know. Anyway, y'all are in charge of part C. Y'all are in charge of part B. Okay? So you can work with your families, divide it up, I don't care. But find the mean median range and interquartile range of those two people. Go.
These are all statistics. These are all statistics. Now I know. Now I know.
Alright, can anybody tell me what Deshaun's mean score was? Chloe, what was his mean? 65 is correct, is what you should have gotten. Can anybody tell me what Deshaun's median was? What was his median? 79, thank you. That is correct. What about his range? 74. Good. Did y'all make it a IQR? Okay. What'd you get as the IQR? What did you get? 60. Yeah, 60 is correct. Good job. Alright. Mayumi. Who has the mean for Mayumi? Jacob, what'd you get? 71 is what I got. You must have missed a number. Sometimes you miss a number. That's why anytime I do the mean, I do it at least 2 or 3 times. Because I always miss a number. Every time. Alright, median. What do we get from median? Josie?
78.
78 is correct. And the range, Emery?
87.
87, good. And did y'all get to the interquartile range? Alright. John, what'd you get for interquartile range? 19 and a half, good. So based off of this information, who had the better score? Why are you saying Deshaun? Which one? Which measurement are you looking at? If I'm talking about who has the highest test score, what am I usually looking at? Their average. So you would want to look at the mean. So who has the highest mean? Ariana. If you look at the range and the interquartile range, those are telling you how spread apart are the numbers. And the bigger the spread, the further they are and the least consistent they were. So, good deal. Okay? So we could say Ariana's because she has the highest mean. Turn the page. Alright, so we've got some vocabulary. Let's use. We have the lower quartile, which is also known as your Q1. And it is the median or the middle of the lower half of the set of numbers. Your upper quartile is what? Q. Do you remember?
Q3.
It's Q3 because Q2 is your median. It is the upper quartile, so it is the middle of the upper half. I told you, math folks like it straightforward. Alright, interquartile range, also known as IQR, is the difference or the range between the upper and lower quartiles on a box plot. You know what the mean is? It's the sum of the items in the data divided by the number of items in the set, also called the average. What's another word for median? Median's the middle. Median's the middle. Now I know. Now I know. So the median is the middle number. Or it's the mean slash average of the two numbers. So this is where you add the two numbers and divide by 2 if it's even. Okay? Range means difference. Range means difference. Big minus small. Big minus small. Between the maximum and the minimum. Y'all did a little bit with MAD last year, I think. Did you? Just a smidge? Yeah. We're just going to do a smidge this year with it too. Okay, we're not going to dive completely deep into it. But mean, or the also known as the MAD, okay, is the mean difference between each value and the mean of the data. So basically we're finding the mean a lot. Yes, ma'am.
For range, what's that second one?
Between the max and the min. Maximum and the minimum.
Well, it's like the same order the median after the
Mean. Alright. At the end of the first week of school, Mr. Parrish asked 15 freshman students how much time they spent studying for the week. He also surveyed 15 sophomores to investigate whether their habits were different. And we have these two dot plots, freshmen versus sophomores. Compare the shapes of the dot plots by describing where their values are clustered in each plot. What is a cluster?
like a bunch of
Yeah, it's like a clump. Or a group, right? So where do we see a large group in the freshmen? Between what numbers?
0.5 and 1.
Right, where this is higher right here. 0.5 and 1. What about in the sophomores?
1.5, 2.
Right, and then there's our big peak right here. So, are their clusters the same? No, their clusters aren't the same. So, we could say freshmen cluster around 0.5 and 1, while sophomores if I could spell sophomores correctly. Are clustered around 1.5 and 2. Did y'all talk about skewedness last year?
Yes.
Looking to see if it was the graph was symmetrical or if it was skewed. You did, you just may not remember it. Symmetrical, what does symmetrical mean? Is something symmetrical? If I fold it in half, it should line up on each other. It should mirror each other, right? If you look here at the sophomores, it kind of mirrors itself. It goes up and then it goes down. Where the hill is in the middle, this would be symmetrical. When we have skewness, this is where I bring out my little dinosaur drawings because I'm obsessed with dinosaurs. I like dinosaurs. Okay? You can draw your graphs into a dinosaur. Okay? Watch. It's so beautiful. Here's his tail. There's his head. And he makes a little... See, there's his mouth. Roar. And there's his arms. I got little arms. Big head. All right, and here's his tail. Do you see his tail? There's his tail. You look for the dinosaur's tail, and what side is the dinosaur's tail on? The right side. You think mine's so beautiful?
Yes.
All right, you look for the right, you look for the tail, and we know that this is skewed right. Now, if my dinosaur tail, Caden, don't be ugly about my drawings.
There's like this one thing.
Reptar.
Yeah, that.
If the tail is on the left, it's skewed left. Guys, I don't know why I draw a dinosaur. It just helps remember. You have to do dumb, corny things sometimes. But ever since I started drawing a dinosaur with it, rawr, and I look for his tail, I'm like, oh, that's where it's skewed. Okay? You could.
Instead of drawing,
But anyways, that's what I did in high school. I just was doodling and I've remembered it ever since. The Scudosaurus.
No, I was gonna say the Grammosaurus Rex.
Alright, so moving on. We got 10 minutes. Let's see if we can get done in 10 minutes. Alright, it says find the median and the mean of each. Okay, I'm not gonna make us find the mean because, well, okay, this is what you can do. If it's on a dot plot, okay, to find the median, it's already in order from least to greatest. You just go boop, 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 boop. Oh, well, all my dots are a 1, so what's my median going to be? 1. Use the graph. For the sophomore. Boop, 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 boop. It's like the Wii game. Boop, 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 boop. I don't know if y'all even played the Wii.
I have.
Then all of these are a 2. So even if I go back and forth, back and forth, back and forth, the median's going to be 2. Now, for the mean, each dot represents the value that's underneath it. So this is a 0, this is a 0. 0 plus 0 equals 0. This is half, 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 half. You add all your halves together, it equals 2. 1, 2, 3, 4. Half, 1 and a half gives me 3. This is 2, 2 and a half, 3. So now I can add those together. 0 plus 2 plus 4 plus 3 plus 2 plus 2 and a half plus 3. I can add all those together. Count by, or divide by how many numbers I had. 1, 2, 3, 4, 5, 6, 7. I end up with 1.1. Do the same thing for the sophomores. This adds to be 2. This is 3 and a half. 10. 5. 6. 4. Add it all up and divide, and you'll end up with 2.1. How do we find the range? Range means different. Range means different. Big minus small. Big minus small. So for freshmen, the biggest recorded value was what? Where's it? 3. There's a dot. What's the biggest number of dots over? 3. Minus the smallest, which is 0. So your range is going to be 3, right? 0 minus 3. All right, sophomores, our biggest recorded number is a 4 minus the smallest recorded number, which was a 1, gives me a range of 3. So both of them have a range of 3. Ta-da! Turn the page. So what does the data tell you about the habits of the freshmen versus sophomores? Based off of this, who spends more time studying? Sophomores. Sophomores are spending more time studying. Alright, we're skipping that turn and talk for now, for time's sakes. Alright, box plot. You got 2 box plots going on here. You got this one that's for 6th grade, and you got this one that's for 7th grade. Okay? They're having a reading contest, and here's their progress. So, label this box with me really quick, just so that we remember. What is this point called?
Q1.
The very first one?
Oh, minimum.
Minimum. It's your min, which means the opposite side is your
Maximum.
maximum. The one in the middle
Q.
is your median, also known as your Q2. So that means this point and these points are left. This is your, well, if this is Q2, then this one is
Q1.
Q1. It comes before it, and the one after it's going to be
Q3.
Q3. And the space between each of them represents how much of the data? 25%. Good. All right, it says describe the shapes of the box plots. What do you notice about their shape? Do they have a tail or do they make a heel? If you were to draw a shape, do they have a long tail anywhere or are they symmetrical?
They're a snake.
They have a long tail. Which side is the long tail on?
Right.
The right. Okay? Both are skewed right because their right whisker is longer. All right, compare the centers of the box plots. Looking at their medians. Look at their medians. 6th grade's median was a 7, and 8th grade's or 7th grade's median was an 8. Are they relatively close?
Yes.
Okay. Both are close, with 6 having a 7 and 7 having 8. Alright, find the ranges and the interquartile ranges and complete. So for 6th grade, range, remember, is your big minus your small. What's the big number? 18 minus 0, so your range is 18. The range for 7th grade is 25 minus 0, which is 20. Your interquartile range is your Q3 minus your Q1. Q3 minus Q1. Your upper minus your lower. So your Q3 was 9 and your Q1 was 3. 9 take away 3 is 6. For 7th grade, your Q3 was 13. Your Q1 was 5. 13 take away 5 is
18.
8.
Oh, 8.
Okay, we're going to skip these two for now. Move it on. Last page. Alright. It says we're going to be looking for the MAD. Remember, the MAD is the average distance from the data points to the mean. It is a measure of the spread of data because it describes the variation or how spread out the data values of the mean are. Alright, find the range of the data. What is the mean number of messages sent in this sample? So first they want us to find the range. So we need what to find the range? The highest number and the Lowest number. So the highest number glancing at it is
119.
119, and the smallest number 70. So 119 minus 70 gives me 49. To find the mean, because the next part we needed the range and we needed the mean. I don't really know why they wanted us to have the range, but if we add all those numbers up and divide by it, I'm not going to make us do it for time's sake, you get 95. This is the first step in finding MAD. Step 1, find the mean. Step 2, you want to subtract the mean from each data point. And you want to take the absolute value. What does absolute value mean? Absolute value is always positive. So I'm going to take 104 and I'm going to subtract the mean and I get 9. I'm going to take 92, subtract the mean, and I'm going to make it a positive 3. Subtract 107 minus the mean, and I get 12. Absolute value 83 minus 75, 83 minus 95 gives me 12. 96 minus 95 is 1. 98 minus 95 is 3. 70 minus 95, positive 25, 4, 24, and 5. So this is step 2. We're going to find the sum of the absolute deviations. You're going to add all those up, and we'll finish at Barren time. But you add all those up, and then you find the mean of all the differences.